So at this point, you already know that there are 5 types of chemical reactions. This video is going to emphasize single replacement and double replacement reactions. So what you have already on this first board are things that you should remember. Single replacement reaction has the equation A plus BC. It's going to yield AC plus B. The hint here, you're going to always have an element plus a compound for reactants and a compound plus an element for your products. It uses the activity series of metals or activity series of halogens chart. This is when an element can replace anything below it on the chart. Double replacement reaction has the equation AB plus CD is going to yield AD plus CB. The hint here is your compounds. You're going to have 2 compounds for your reactants and 2 compounds for your products. It's going to form a precipitate, which is a solid. It's using the solubility rules, and this is going to allow us to determine if a compound is going to be soluble or insoluble. So at any point, if you don't understand how we're determining whether to use the activity series of metals or the solubility rules, you reference this material to make sure whether you have a single replacement reaction or a double replacement reaction. So activity series of metals are located on page 6 of your chemical reference chart. So we have that actual activity series of metals chart here and our activity series of halogens here. We have 2 examples for each, and we're going to take some time to practice and make sure we understand how to use them. So the first one we have zinc, which is Zn plus sodium chloride. So here we're trying to replace the sodium with the zinc. So we locate the zinc. The zinc is down here, but our sodium is up here. This means that our zinc can only replace the things below it, so it's not able to replace sodium. So no reaction occurs here. Now we have sodium and zinc 2 chloride. With our sodium this time is up here and our zinc is down here, so the sodium can replace the zinc. So we will get NaCl plus Zn. And now with our activity series of halogens, you have S through I2. The first example, you have Br2 plus KCl. That means the bromine is trying to replace the chlorine. Your chlorine is up here, your bromine is down here. So bromine can only replace the iodine, not the chlorine. So, no reaction. Bromine, 2Ki. Your iodine can be replaced by the bromine. So we'll have KBr plus I2. And we write the 2 because iodine is diatomic. So let's move on to some more practice. So if you got to see any of that, then you got a head start. So here you have your rubidium, K2Cr2O7. This is dichromate. So potassium dichromate, we're trying to see if the potassium can be replaced by rubidium, and it can. So this is going to be Rb2, Cr2O7 plus K, and the numbers here are based upon crisscross or balancing out your charges. For the second one, we have calcium plus silver phosphate. So now we're trying to determine if the calcium can replace the silver, and it can. So we're going to have calcium. Now this time calcium has a 2 plus charge, so this is going to, and phosphate has a -3 charge, so Ca3 PO4 2 plus Ag. Then here we have our zinc plus iron 3 nitrate. So the zinc can actually replace the iron. So this will be Zn. So nitrate has a -1 charge, so NO3. But zinc has a +2 charge, 2 plus Fe. Then we have bromine and lead 3 chloride. So now we're going to use our activity series of halogens. So bromine is below chlorine, so it cannot replace the chlorine. No reaction will occur here. Aluminum plus magnesium carbonate. The magnesium is actually below the aluminum. So, because magnesium is, the aluminum is below the magnesium, so therefore this reaction will not occur. And then we have H2, which is hydrogen gas, plus your copper hydroxide. With the copper hydroxide, the copper is below the hydrogen, so the hydrogen can't replace the copper. So you actually get water and copper. So next we're going to try out our solubility rules. So with our solubility rules, they're coming from page 6 of your chemical reference table. So start with the top. They're broken into solubility versus insolubility. So first, all nitrates, acetates, ammonium, and group 1 salts are soluble. All chlorides, bromides, iodides, except when bonded with silver, lead, and mercury 1 are going to be soluble. And then you have your fluorides that are soluble except when they're bonded with group 2 alkaline earth metals, lead 2, and iron 3. So all sulfates are soluble except when they're bonded with calcium, strontium, barium, mercury, lead 2, and silver. So it's telling you all the things that are soluble, but there are some exceptions that will make those compounds insoluble. Here you have insolubility rules. They also have exceptions, but those exceptions are going to cause those those compounds to become soluble. So 5, all carbonates and phosphates are insoluble, except when bonded with group 1 alkali metals and ammonia. Rule 6, all hydroxides except group 1 alkali metals, all hydroxides are insoluble, except when bonded with group 1 alkali metals, strontium, barium, and ammonium. All sulfides are insoluble except when bonded with group 1 alkali metals, group 2 alkaline earth metals, and ammonium. And rule 8, all oxides are insoluble except when bonded with group 1 elements. So if you look, we have some examples, and how you're going to tackle these examples are by stating what the rule number. So 1 through 8 are, is that going to make it soluble, or is that going to make it insoluble? So we look for the first one. We have strontium sulfate. So sulfates are part of our solubility rules, which would actually be number 4. So all sulfates are soluble except when bonded with calcium, strontium, barium, mercury, and lead 2, and silver. So here it is bonded with a strontium. And once again, this is rule 4. That means this is actually going to be insoluble. So then we go to manganese carbonate. And carbonate is a part of one of your rules. It's going to be a part of the insolubility rules. However, if you read, all carbonates and phosphates are insoluble except when bonded with your alkali metals and your ammonia. So manganese is not a part of any of those exceptions, so this also is going to be insoluble. And that was rule number 5. And we're going to write insoluble. And if you didn't understand why I used red and blue, even though one was soluble and one was insoluble, it's based upon the colors of the rules, so whether it came from the solubility rules or the insolubility rules. So now it's time for some solubility practice. So, solubility directions here, we're going to circle the compounds that will be precipitates. This means the ones that are going to dissolve or are soluble. So, we have a problem. Now we're going to write the rule number to let us know whether something is soluble or not. So once again, you're going to reference your solubility rules. So K2Cr2O7, that's potassium dichromate. So once again, we're here. There are no rules with the potassium. There are no rules with the dichromate, but there are rules with the potassium. So remember, potassium is a group 1 alkali metal. It is soluble. So that was rule 1. We're going to circle this. Then you have silver plus phosphate. Phosphate was also one of your rules. Your phosphate is a part of the insolubility rules, and it's insoluble except when bonded with a group 1 and an ammonium. So this is silver, so that means that it's not a part of exceptions. It's going to be insoluble. So this was rule 5. And then you have iron nitrate. Your nitrate is a part of rule 1 for your solubility. And it says nitrates, acetates, ammonium, and group 1 salts are soluble. It has no exceptions. So that makes this soluble, rule 1. So here you have your sulfate. Your sulfate is what you're going to be looking at. That was rule 4 under solubility. And it's soluble except when bonded with calcium, strontium, barium, mercury, lead 2, and silver. This is your barium. Therefore, it is not soluble. So we're not going to circle it. Copper and hydroxides. We know that hydroxides are soluble. However, hydroxides have the exception with group 1, strontium, barium, and ammonium. So copper is not a part of that, so it will not be soluble. But that was rule number 6. So lead 3 chloride, you're going to look under your chlorides. Chlorides are under rule 2 for solubility. All chlorides, bromides, iodides, except silver, lead, and mercury are going to be soluble. So this is bonded with your lead, so it's not soluble. That was rule 2. Rule 3, your next one, you have magnesium CO3, and your carbonates, what you're looking at, is typically insoluble, except when bonded with your group 1 or an ammonium. Magnesium, however, is group 2. It's an alkaline earth metal, so it does not apply. So this is rule 5, and it's also insoluble. Here you have CaCl2. Your CaCl2, we're going to use the chlorine. Your chlorine is under solubility. It's soluble except when bonded with silver, lead, and mercury. Calcium is none of those things, so it is soluble. That's rule 2. We will circle this one. So of all these problems, these were the only ones that were soluble based upon exceptions or whatever the rule said. These were all the rules that we covered. So the more you practice, the easier that it is. Good luck with this.